Welcome to Geopod, where we look at the world and current events through geospatial analysis. I'm Andrew Patterson, a teacher at Coppell High School. Who else do we have around the table today?
I'm Bhargav, student. I'm Sathvik Srinivasan.
I'm Bilal Haque.
And I'm Nihar Pathare.
All right, today we're talking about Mars. There's a lot of information, a lot of exciting news going on about discoveries on Mars and potentially sending humans to Mars. And there's a lot of sci-fi movies that represent our desire to reach out and explore science and the universe beyond what we know here on this Earth. So what's exciting? What's going on right now, guys?
Okay, so if you guys watch the news today, you probably noticed most of it is filled with political either scandals or just information about the candidates, and a lot of information about other areas like science and social studies is often misrepresented. So today we're going to give you an update on stuff that's happening in the realm of science, specifically space science. So a couple of months back, new findings from NASA's Mars Reconnaissance Orbiter produced images of hydrated minerals on downhill slopes. And specifically, these planetary scientists have detected the presence of hydrated salts at the Hale crater. What I'm talking about is water. So the darkest streaks from the images appear to flow over time, and they darken and flow downstream during the warmer seasons and then fade during the cooler seasons. So scientists infer that these dark spots occur because the hydrated salts lower the freezing point of a liquid brine. And so if you've ever been in a science class, it's kind of like how salts are used on Earth to melt snow faster. It's the same process. And so observations of this red planet indicate that rivers and oceans may have been prominent features billions of years ago, meaning that Mars used to be a wet world that could have supported microbial life. And because the planet is much smaller than the Earth with a thinner atmosphere, liquid water evaporated at a faster rate, and more escaped into space, so less was there to fall back down. The European Space Agency's Mars Express has captured images of a possible sheet of ice the size of Texas and California combined, in the region between the equator and the North Pole of the planet, causing strange craters to form. However, there hasn't been any confirmation. So you must be wondering, what does water on Mars mean to us? Bhargav?
Alright, let me drop some knowledge on you. Water on Earth may seem like a common element, but in reality it's a scarce resource within the universe. The presence of water is so interesting on Mars because it indicates life. Only Earth is known to support life as of now, so scientists hope that the presence of water may indicate that life is present in the rest of the universe. However, although water may be present on Mars, the atmosphere itself may not be able to support life. So according to the New York Times, NASA discovered that solar storms were the cause for the loss of Mars' atmosphere. This was first discovered when MAVEN, or the Mars Atmosphere and Volatile Evolution Mission, observed during a solar storm on March 8, 2015, that the rate of charged atoms escaping the atmosphere was 10 to 20 times higher than normal. So they believe that the loss of the atmosphere was a result of erratic solar storms during the youth of the sun, which caused the atmosphere to rapidly decrease in its thickness, which is important because even if water could maintain life on Earth, as time continues, the planet's atmosphere would continue to deteriorate, meaning that future manned explorations would have to accommodate for the lower atmosphere.
Nihar, will you tell us more about life on Mars?
So recently, scientists have found that on Mars, salts on the surface can absorb atmospheric water vapor and trap it in their crystal structures. The same scenario is seen in Chile's super dry Atacama Desert, which allows it to support extreme forms of life. This is why scientists theorize that the same setup on Mars would allow for some types of life to exist. In 2004, Mars Express detected the presence of methane gas, which could have only been produced by volcanoes associated with geological activity, or by living organisms. Methane is also a very short-lived gas because it is broken down by sunlight, so whatever produced the methane must have done so relatively near in time.
Alright, so yeah, we talked about water getting discovered on Mars and possible signs of life, but what are we actually doing right now? Well, next year, the European and Russian space agencies will launch a pair of missions called ExoMars to further look for the presence of methane. Now, ExoMars is just a fancy name for exobiology on Mars. And what is exobiology? Exobiology is the process of culminating evidence on extraterrestrial matter, or terrestrial as in land, to find out signs of organic life. This astrobiology mission is currently under the development by the European Space Agency, which is known as the ESA, in collaboration with the Russian Federal Space Agency. Now, for a quick synopsis, methane is a vital biochemical that is essential to life. If life does exist on Mars, it is likely beneath the surface. That's why the second mission is being sent to drill 2 meters beneath the surface and collect more soil samples to test for presence of life. When they drill beneath the ground, They will most likely test for organic matter, such as hydrocarbons and nitrates, and these are evidence of life.
Okay, so we've sort of spurred a lot of facts on you guys, but let's go into a little bit of an analysis here. So, when we think about all these NASA missions, it seems great that yes, we're doing stuff, we're looking more into Mars, but we gotta realize that there are threats when you temper with stuff we've never done so before. So let's talk about what are potential threats associated with NASA and other countries' space missions. Nihar?
Well, for one, planetary scientists need to be extremely careful when planning on sending spacecraft to Mars. The spacecraft used need to be cleaned and sterilized carefully before landing in order to avoid contaminating potential water sources found on Mars. If hitchhiking microbes were to survive the journey, it is possible that they could contaminate the red planet. This would further complicate any detection of life on Mars because it would be harder to differentiate between native life and introduced life from Earth. Also, at this point, we don't have the capacity to stop an invasive species from spreading throughout the planet.
So to conclude this podcast, let's really talk about the big picture. Why is life on Mars important to us?
All of our knowledge about how our ecosystems work and how biology works stems from Earth. And while there is diversity in the Earth's ecosystem and ecology, it's still all based on the same biological frameworks and core concepts. But let's say we do find life on Mars. A discovery of Martian microbes may not have the same equivalent of DNA, genes, or elements of biochemistry as we currently know. Life on other planets may have a completely different structure from anything on Earth, which would actually be beneficial for scientists to study how life develops based on the environment. It may also help in determining more about the origins of our solar system itself.
So I may go off on a little tangent here, but this is a theory that I read online which sort of makes sense in terms of what we know now about Mars and what we potentially could discover if we find water. So if Martian microbes have identical biology as organisms on Earth, then a new explanation for life on Earth would come from our neighboring planet. Since Mars cooled faster than Earth, it would have started biological processes much sooner than Earth did. Hence, if the biology was the same, the only way Earth would have developed biological processes would be if life was somehow exported from Mars. So, this would mean that Martian rock ejected from the red planet would have had to have hit Earth as meteorites and then spread. And since we've already discovered Mars origin meteorites on Earth, this is a new plausible explanation for life origins on Earth.
So in the end, this discovery about possible signs on life in Mars and water streaks in Mars is instrumental to our developing scientific community. NASA has not only identified extraterrestrial life, but a possible sign for new developments in space technology. For the past 200 years, we've only been focusing on who we are and what we do in the Earth in general. Now we're actually extending our ideologies to something big. Right now we're discovering life on Mars, and right now we're discovering water. But in another century, we could be discovering food or even possible signs of biomes in Mars.
And I think another big point we have to make is I feel like space has lost a lot of interest in students today because, in the 1960s and 70s when space was flourishing with going to the moon, and I think there was a lot of interest in space, and as NASA's influence has deteriorated over the past decade with defunding from the government, I feel like space is not a big deal now in school, and I think the more discoveries we make on Mars or potentially other planets, people will be more interested in space, and this will spark more exploration into Mars and more government funding, which is exactly what NASA needs. Thank you so much for listening to this podcast. I hope this podcast has sparked more interest in you about science and space exploration. I hope you do your own research, and see you next time. Also, on a side note, if you are interested in joining this club and you like the idea of making podcasts and learning more about geography and how it influences the world around you, come and join the Coppell Geographic Society. Either talk to Mr. Patterson or me. Have a nice day.